Macro Review Unit 3. First, we'll start with the aggregate expenditures model, which corresponds with Chapter 8 in your textbook. First, we look at the graph, and you'll want to sketch this down. Hopefully, you can label the axes and the two different lines on here without looking at the next slide. Here are the labels. So you have aggregate expenditures on your y-axis and real GDP on your x-axis, 45-degree reference line, and then your aggregate expenditures line. So it says C plus IG plus G plus XN, which is our GDP, but we could also just call it the AE line or the aggregate expenditures line. Next, we mark the equilibrium point, so where the aggregate expenditures line intersects the 45-degree reference line, that's equilibrium. That is where the economy is currently functioning, so how much is actually being spent on goods and how much real GDP is created in the society. Below, after we do the consumption model, we'll break apart some elements here of the graph. The AE model with a closed economy, meaning, okay, we're only looking at consumption spending, looks exactly the same as AE. It's just lower because as you add IG, XN, and G, that consumption line will continue to go up. But what you might have noticed is that the slope is the same as the consumption line and the AE line, because after you have your consumption curve, then you add definite amounts of government spending, investment, and exports. And it's not surprising that consumption would determine the slope of the AE line, and everything else is just added to it, because we know consumption is the greatest part of GDP. That's something that we've talked about before, that the greatest component of the four in GDP is consumption. So they're the ones that determine what the AE line is going to look like. Do note that on the x-axis, it is national income. So once we add IG, XN, and G, we change it to real GDP, but the AP test may draw it as national income if they're just talking about consumption. So just be aware of that. Couple of notes on the graph. So it says graph notes, slope. We know that the slope of the consumption curve or the aggregate expenditures curve is going to be the MPC. So you should write that. The slope of AE is going to be the MPC. So they might give you a problem where they want to know what the multiplier is or how much the government should increase in government spending for an economy. And in order for you to calculate that, you need the MPC. Well, if they give you this curve in 2 points, you can calculate the slope to get your MPC to then get your multiplier. Do note that in this graph, if they had given you a value on the x-axis where the consumption intersects the 45-degree reference line, they may not give you the y-axis data, but you can still calculate that, because if it's intersecting the 45-degree reference line, any point on the 45-degree reference line has the same x and y value. So if they give you a y value on the 45-degree reference line, you automatically have the x value, and vice versa. That's a tip for something that they may do in problems. Also, you want to note that the reference line, part B, means that the theoretical, if you spent all of your income. So if you're on the 45-degree reference line, then you are spending everything that you're making. So looking at that, then part C, type of problem hint, that was just me saying that if they only give you the x value, you don't have to write anything in for part C. That was just if they give you the x value on the 45-degree reference line, you know what the y value is on that point. Breaking even, that's the equilibrium point. That is the intersection point. Part E, the gap, you want to label the savings and dis-savings up on your graph. So intersection point, you're spending what you are making. To the left of the intersection point, that is dis-savings. The distance between how much you're spending, consumption is on top, so you're spending more than what your income actually is. To the right of it would be savings. So the reference line is what you would spend if you spent everything you had. Well, you're spending, your consumption curve is less than what you would if you spent everything. So obviously the distance between the two would be your savings. Okay, now we'll redraw the graph to show gaps, recession and inflationary. The first one you have is an inflationary gap. So if you look here at this graph, redraw it, push pause, redraw your graph. Full employment means when you're maximizing all of your resources. That's where your full employment would be. If you notice your equilibrium point, it's actually above what it should be. So this is an inflationary gap. So you can actually label that distance between where you're operating and what full employment would be, and that's how much your inflationary gap is. In order for you to correct this problem, what would have to happen to your aggregate expenditures line? Hopefully you said that the aggregate expenditures line would have to shift down. So if you put your pen up to the graph and pretend like you're the aggregate expenditures line, and you see that you're intersecting above full employment, if you shift it down, your intersection point, shift it down until the intersection point is at full employment. So that would mean you're decreasing your aggregate expenditures along the y-axis. So you're decreasing your spending. Well, that makes sense. That's going to cause the inflationary gap to go away or for your GDP to go down. So I'll say that again slowly, or you can rewind it. But in order to get rid of the gap, what you would have to do is decrease your expenditures, stop the society from spending so much. That would help inflation, or the inflationary gap. So your AE line would shift down until the point where it would intersect at full employment. So full employment, the reference line and the AE line all intersect at the same place. You're operating at full employment. So you may want to try that on the graph. The opposite then would be a recessionary gap. So that's when you're operating below full employment. So you can go ahead and draw this example here and be sure to label the gap as the recessionary gap. So the gap is just the difference between where you're at and where you should be. In this case, you're less than you should be, so it's called a recessionary gap. Okay, in your packet, you're going to want to skip Part 5 multiplier effect and go right down to the bottom of that page, Part 6 shifts in aggregate expenditures. So it just makes more sense for us to talk about, okay, here's the graph. Let's talk about what shifts the graph. So go down to Part 6, shift in aggregate expenditures. So if C plus IG plus XN plus G, if any of those change, then AE shifts. Well, let's talk about shifts in consumption. So the four determinants are consumer wealth, household debt, interest rates, and expectations. So you may want to go ahead and write a couple of things down for that. For consumer wealth, if wealth increases, aggregate expenditures increases. So in parentheses, I would write it shifts up. Household debt, this is the tricky one. If household debt goes down, people reduce their debt. That means that they've sort of put a check on their spending. They've stopped their crazy spending habits. So that would make aggregate expenditures go down. So if household debt is reduced, then aggregate expenditures goes down. People spend less. If household debt increases, that means people are spending more. So aggregate expenditures would increase as well. For interest rate, if interest rates go down, then consumption increases. That makes sense. And then expectations, if you think the prices are going to rise in the future, you're going to buy a lot now. So someone in class said, well, that's kind of a self-fulfilling prophecy. But so be it. If they expect prices to go down in the future, then they'll hold off and their aggregate expenditures will go down in the present. Skip that Part D I just talked about, the expectations. It's a typo that there is that parentheses with wealth, expectations, interest rate, and debt again, and then consumption, stock of capital goods. So once you have Part D written down, you can go on. So we could have shifts because of IG or investment. So things that would cause that, one, the price of inputs. If oil costs more now, then aggregate expenditures, investment will go down. So AE will go down. If price of inputs, let's say wages, if they say wages, they're always talking about the shifting of investment because it's a resource. So if wages go down, then aggregate expenditures will go up because investment has increased. Two, interest rates. When interest rates go up, then investors invest less. So aggregate expenditures will go down. That makes sense. If they're going to have to pay a higher interest rate, they're not going to invest. They're going to borrow money later. Technology, if it speeds up, aggregate expenditure, investment goes up if technology gets better. 4 may be kind of tricky, so you want to write this down. Stock of capital goods on hand. Stock means how much you have available. Capital, those are goods that produce, tools that produce goods. So factories. If your stock of factory machinery has gone up, you're not going to invest in making more factories. So if your stockpile increases, your investment goes down. If I'm expanding a corporation and I keep investing in new factories and all of a sudden, I have a stockpile of 6 factories that aren't being used, I'm not going to invest anymore. I'm going to stop investing. So if your stock of capital goods goes up, the investment goes down. Same with changes in inventory. Inventory is simply goods that would be in consumption if they had actually been sold, but they hadn't. So they go in the inventory, they go in the stock room in the back. So if your inventories keep going up, you'll stop investing. Why invest money to produce all these new goods when you haven't even sold the ones you made from the year before? And then finally, excise taxes and subsidies. If we're talking about taxes for a producer, an excise tax is a tax on a producer. So if the government taxes a producer, they're going to invest less. If they give a subsidy, then they're going to invest more. Some final thoughts on the model, on the graph. When people spend more, then aggregate expenditures goes up. So that the graph would be shifting up. The greatest B component of GDP, hopefully you remember from class or just before, is C, consumption. It's the biggest component, the biggest determinant of GDP is how much people personally consume. That affects the economy the most. Well, part C, what's the greatest determinant of consumption? What's the biggest deciding factor in how much we spend? Of course, our disposable income. That brings us to part D. 2 things you can do with DI, disposable income. That's your money at your disposal after taxes. You should write that down. Money at your disposal after taxes. You can either save or spend. E, savings is hopefully you said leakage. So then F, investment, IG is an injection into the circular flow model. So that's for E and F. The most stable part of GDP is consumption. The most volatile part is IG, investment, because they're so sensitive on interest rates. Something interesting, if exports go up, then obviously your AE goes up. I don't know why I said that was interesting. If imports are greater than your exports, then your aggregate expenditures will actually go down. So if you're importing more than you're exporting, that's a negative XN. So your aggregate expenditures curve will go from C plus IG plus G minus whatever the trade deficit was. Okay, this is what I think is interesting, or something you may have to think about. This goes back to our China example. If the dollar depreciates, so if the value of our currency goes down internationally, that means our goods are cheaper to the rest of the world. So our aggregate expenditures curve actually increases. If our dollar depreciates, our AE increases because more exports are being sold because they're cheaper. Again, China's trying to devalue their currency and depreciate their currency so that people continue to buy Chinese goods and they can build more factories and employ more workers. Some criticisms to the model. The biggest ones are that price level, or the biggest one is that price level is not accounted for in this model. So price level is not, or interest rate really, are not on the graph, like on the ADAS model, which was developed later, which actually puts price level to account for inflation actually on the graph. So let's move on to the multiplier. So you're going to want to flip back to the previous page and go to part 5 for the multiplier. Okay, so the multiplier is something that we looked at both in the AE model and the ADAS model. Primarily, you start with, maybe you're given a graph or just a word problem. But let's say you're given a graph with the AE model, and you're going to go back to look up on your graph to the recessionary gap. And what you're going to see there is that gap. That's the amount, the change in real GDP that you need the economy to grow. You need that much GDP to be created. So in the multiplier, where we have real GDP equals change in initial spending times the multiplier, the change in real GDP part of the equation is right there on the graph, the difference between full employment and where you are actually producing. So what you would need to calculate then is what's the initial spending that needs to go into the economy to get that recessionary gap amount filled. And so you need to know the multiplier to figure out that kind of problem. So let's start to define some of these terms. Part A says marginal propensity to consume, and you should put MPC. And conceptually, that is just the likelihood that someone's going, or the amount that someone is likely to spend of their extra income. So you may want to write that down here. MPS, marginal propensity to save, is the amount of extra income a person is likely to save then. I had it on the last paper, and you're going to want to write this down after MPS is the MPC and the MPS. MPC plus MPS has to equals 1, because it's a percentage, a likelihood that you're going to spend or save. But there are only two options, spend or save. So the percentage you're going to spend is the opposite of what you're going to save. So if you spend 60%, you're going to save 40% by default. So it's always going to equal 1 because we do the propensities in hundredths, 0.75 or 0.50. So an example then, if a man, and I would write this down, has $500 and he earns a $100 bonus, if he spends 60, what's his MPC? Hit pause and figure this out. Hopefully what you came to the conclusion is that his MPC is 0.6. This is because you took $60 is 60%, 0.6, 60% of the $100 bonus. So what he spent, the change in what he spent, 60 over the change in his income, which would be 100, you would get 0.6. So for the equation for MPC, you can write under A, is you can write change in spending over change in income, but I think you can just do that logically. The reason you do not take the 60 over the 600 is because you're looking at the change in income, which was $100. You already have 500. So multiplier, let's start talking about the spending multiplier. I would like you to put spending multiplier under part C. And we're talking about how much initial spending is amplified in the economy. So we put in an initial amount of injection into the economy. How much real GDP is that going to translate into being created in the economy? So let's go ahead and get the equations. So the first one is 1 over MPS. That's the easiest one to use. You can add to that 1 over 1 minus MPC. I think it's foolish to almost write this down. I think it makes it more complicated. If you know it's 1 over MPS, then if they give you the MPC, you know MPC and MPS equal 1, so just take the difference. So if I tell you the MPC is 0.2, you know the MPS is 0.8. So you don't, what you've done in your head is the second equation, 1 over 1 minus the MPC. You've done that implicitly. So I'm not sure it's worth writing down. This is the other biggie though. Change in real GDP equals multiplier times initial spending. If you look at that, I can take real GDP divided by initial spending to isolate the multiplier, like to get a third equation for the multiplier. But conceptually, I think it's just easier to think of it this way, that you have your initial input. Think of that initial spending as literally money changing hands, and the multiplier. How much money, or how much is that money multiplied into real GDP in an economy? So remember that the idea is if the government increases spending by $5 billion, that transaction causes more people to have jobs who then start buying more. And so not only did your government spending go up in your C plus IG plus G plus XN, but so did your consumption, because now more people have jobs, so they're going to go buy more jeans and shoes, etc. So that's where the multiplier comes from. You're going to want to use the multiplier practice problems I gave you, and then obviously your practice safety questions. Really quickly, let's differentiate between marginal propensity to consume and average. you will most likely not deal with the average propensities. So that is not looking at how much you're spending based on changes in your income. That's just saying out of your totals. So APC, or average propensity to consume, is just the equation, the amount you consume over your income. APS is the amount you save over your income. So the difference is then you're not looking at the change. And so this is where, if we went back to our example problem, we would take $60, what he spent, over his total income, which would be $600. So I just wanted to differentiate between the two. If you're confused about that, let me know. This concludes part 1 of Unit 3 review. You may go to the next video for the ADAS model and fiscal policy.